Hi, this is the second video presentation on how to type math in LaTeX, and here is a really complicated math formula, and you can ask, how on earth could I learn how to type this? How do I put in all the markups to get such a complicated output? Well, of course, most of the time you don't have to type formulas this complicated, but in this video presentation and the next I will show you how to do this, and I will try to convince you that this is really not very complicated to do. The key to understanding how to type math formulas is to learn about the building blocks from which formulas are put together. And I group them as arithmetic, binomial coefficients, congruences, delimiters, ellipses, integrals, math accents, matrices, operators, roots, and text. Most of it, of course, is meaningful to you. Everybody knows what is a binomial coefficient. Two of these groupings are probably a little bit LaTeX-like, but you will see in a second what they mean. Maybe not in a second, maybe in a minute or two. Let's go through these groups, the building blocks. We start with arithmetic. There is nothing surprising here. Addition, subtraction, division, multiplication is typed exactly as you would expect it to be typed. For multiplication, we also have the dot as a product with the command c dot, and the times, the x, with the command times. Note that in displayed formulas you can use the frac command for fractions. Normally it is not recommended that you use the frac command in inline formulas, because that will really destroy your interline spacing. The next is subscripts and superscripts, and there is not much to say about it. The subscript is with the underscore. Here the last example had a subscript and a superscript. It doesn't matter in what order you give it. LaTeX will typeset it properly. And the only thing you really have to learn is that there is one thing that is superscripted automatically, and that's the prime. You just type f prime to get f prime. You don't superscript the prime. Binomial coefficients are done with the binom command, which has two arguments. And congruences are done with, first of all, with the equiv command to get the 3 bars, and then we have special commands to do the last part. Pmod will do parenthesis mod, and the argument of pmod will be put here, in this case lowercase theta. This without the mod word is the pod command, and there are a few more variants. These two are the most often used that you can find in my book. Delimiters is probably a LaTeX terminology. In mathematics we talk about parentheses and bracketing and stuff like that. Typically you use parentheses or square brackets for bracketing, but LaTeX gives you something special. If you take a pair of parentheses, like here in this example, here is the left parenthesis, here is the right parenthesis, and you modify the parenthesis with the left command and the right command, the parenthesis will stretch to include the formula which is in between. So in this case it is like pretty high. Two more examples with vertical bar modified by left and right, and double vertical bar, which is backslash vertical bar modified by left and right, will give you this. Note that this is still taller than what you would get from backslash vertical bar, because a squared is taller than, say, a would be. There are a whole bunch of delimiters, and in the short course in Appendix B6 or in my book you find all of them listed. Just take a look at the list, and if you need any of these guys, you know where to look them up. Ellipses, that is 3 dots in text, is done with the dots command, and it will take care of the spacing between the dots. For heaven's sake, don't type dot dot dot. That will provide you with 3 dots but awful spacing. In math, again, most of the time you can use the dots command, but in math there are 2 types of dots. The low dots that you use, say, in between 2 commas, and the center dots that you use, say, in between 2 plus signs. And most of the time LaTeX will know which one you want. There are actually 5 or 6 kind of dots, ellipses that you use in mathematics. See my book for more detail. Integrals. That's done with the int command. There is nothing to it. And math accents. Now that's a difficult topic because math accents should not be confused with text accents. However, math accents share with text accents that they should be done with commands. The 4 most often used are done with the commands bar, hat, tilde, and vec, which will produce a bar and a hat and a tilde and a vector and arrow placed on top of the character. And of course there are many more math accents than that. They are all listed in Appendix B8. Take a look at the list. There are 2 groups of them, and if you will need any of these, go back to Appendix B8 and look up the one that you need. Again, remember, math accents are always done with commands, and don't ever use a text accent in math. Matrices, now that's a very important topic. The matrix environment just produces a matrix with no parentheses or anything. In every line, the columns are separated by ampersands, and the end of the line is indicated by the double bar, which is a line separator. The distinction is that since a line separator, it has to go only in between 2 lines, so the last line doesn't need it. Were you to put it in the last line, you will get a blank line following it that you wouldn't want to. Of course, you will get matrices with parentheses, with the p-matrix command, with vertical bars, with the v-matrix commands, and there are lots of other variants. See my book. Operators, that's probably LaTeX terminology in mathematics. We don't use it. Operators are really names of functions. 2 typical examples would be sin and lim. Note that if you just type sin(x) for sin x, you will get this, which looks like the product of 4 variables, sin and x. To get the proper display sin x as you wish it, you have to type the sin command. That's an operator. A more complex display is given by the lim operator, and if you want to see all the operators, you have to go to the appropriate appendix, which I'm going to find in 1 second. Here are all the operators. They come in 2 groups: pure operators like sin, and operators with limits like lim. The fun starts, however, with large operators like sum and like product, which have much more complex displays. They are done with the sum and subscript and superscript, and the same way the product is done with prod. And there are a whole bunch of them in LaTeX, which are shown in Appendix B7.1. You see there is a whole bunch of them, a whole bunch of integral operators and complicated products and unions and intersections and meets and joins and fancy ones that you would want to use. Remember that if you need a construct like that, look it up in the appropriate appendix which ones are available to you. Roots is a simple topic. Square root is sqrt. the argument goes under the square root. It could be any formula. And if you want nth root as opposed to square root, n is an optional argument, like in this example. LaTeX has the ability to change the position of this n if necessary. Look it up in my book. There are really very fine adjustments you can make. And finally, we have text. Occasionally in math, like in this example, a equal b comma by assumption, we want to type text, in this case by assumption. You do it with the text command, which is a really intelligent command. If a text goes into a subscript, the size of the text will be appropriately shrunk. Same with superscript. This also shows you that this distinction of typing math or text is really precarious, because now we are typing text within math, and so in the text command the text rules apply, for instance the blank space rule. But of course, if you say by assumption and you follow it with a math formula, that part of it will be again typed in math and the math rules apply. So what you are in, text or math, that's almost like a recursive definition. You don't have to worry about it in actual applications, it is clear. So let's try to summarize what we have been doing. There are these many building blocks: arithmetic, binomials, congruences, delimiters, ellipses, integrals, math accents, matrices, operators, roots, and text. You should know of all these building blocks. If some you don't ever use, like I have never used integrals in a published paper, just look at it once and just know that in case you need it for some reason, look it up. All these topics are discussed in much more detail in my book. Please look up the details if you have to go further than what's discussed in this short course. Nonetheless, be assured that most every need you have is covered by the few examples we have given. In the next video presentation, we will show you how to put together a complicated formula like this from the building blocks.